Hello, I'm Kathleen Coleman, and today I'll be discussing Physics 2211, Lab 3, the mass of a black hole. So this lab has two parts. In part 1, you need to find the mass of a black hole, and in part 2, you have to get close to a black hole so that you can observe it without getting sucked into the black hole or crashing into the orbiting planet. So for part 1, you need to understand that momentum is mass times velocity, that dp dt, so change in momentum over change in time, is equal to F net. F net's parallel and perpendicular components add to make F net. And also, you can use that to say dp dt equals dp dt parallel plus dp dt perp. And then that can be further expanded by the product rule. Also, force of gravity is negative g times m over r squared times r hat. And then you can use the equivalency with dp/dt to say that the magnitude of dp/dt equals g times m1 times m2 over magnitude of r squared. And then you can manipulate that to say that m2 equals magnitude of dp/dt times magnitude of r squared over g times m1. And then for part 2, again, you just really need to know about the force of gravity. So here's my code for part 1. So I just edited the seed code to make it unique to my email, added in the star mass that was given, and made delta t equal to 1 day in seconds, and basically just edited what needed to be edited in the code. So, changed delta v to v final minus v initial, delta p to p final minus p initial, said that dp dt equals delta p over delta t because it is by definition. And then found the parallel and perpendicular components of dp dt, which were thus the parallel and perpendicular components of F net. And then I used that to find the mass of the black hole, but the mass of the black hole will vary slightly each time, so I also averaged them and got an average mass for the black hole. So here is the result of part 1. You can see F net is always toward the black hole, and it gets bigger as it's closer, and its components add to get F net. And so here we have the code for part 2. I just changed the black hole mass to make it the average of the black hole mass that I got in part 1. And then the ship speed, you just get by trial and error. So the two main things you need to find for this part are F net on the planet and F net on the ship. So the way you find F net on the planet is by finding force of the black hole on the planet and the force of the ship on the planet. And then the way you find F net on the ship is finding the force of the black hole on the ship and then the force of the planet on the ship. And then you use that information to apply Newton's second law and the position update formula so you can see what the next position and velocities will be. And here's the result for part 2. The cyan is the orbit of the planet and the magenta is the path of the spaceship. In part 1, the system was the black hole and the surroundings were the star. And in part 2, this system was the spaceship and the surroundings were the black hole and the planet. Some possible sources of error were approximation with the constants, guessing with the speeds, and then also having to average the mass of the black hole. The fact that there were different masses each time for the black hole means that there was probably some sort of approximation going on within the program. So what is the difference between F net and its components and dp dt and its components? Well, mathematically, there is none. They're the same. However, the rate of change of momentum can be directly observed by using velocity and mass to find momentum as a function of time. And we know F net is equal to dp dt, but we can't know F net directly without the mass of the black hole, which defeats the whole purpose of the lab because we don't know the mass of the black hole. So instead we use dp dt. What would the velocity of your spaceship need to be to enter an orbit around the black hole? So I have here what my velocity needed to be, and I have the resulting orbit that came out of that.